Today's lesson is going to involve absolute value once again, but this time we're not going to be dealing with equal signs, we're going to be dealing with inequalities. So the first thing we should probably know how to do is how to actually pronounce this problem right here. So if we remember that absolute value means distance, we can think the distance to x is less than 3. So basically, x would be any number that has a distance less than 3 from 0. So if you think about the number line, you want to think numbers that are within 3 spaces of 0. So there's a whole bunch. We have like negative 2.9, that's within 3 spaces, negative 2.8, all those possible decimals, the negative 1, 0, 1, 2, and even to the positive 2.99, etc. So there's a lot of numbers that are within 3 spaces of 0. So an easy way to show all of these answers is to just simply put it on a graph. So obviously there are two numbers that are exactly 3 spaces from 0, negative 3 and 3. Since we can't actually have 3 spaces from 0 because it's not inclusive, we still want to use open circles, but we want to make sure we shade the section that would contain all of these numbers. So we're going to shade the section that's in between these points. So all of these numbers would be contained in here. So an easy way to present that answer would be to use a compound inequality. So the way we show answers to this is we want numbers that are less than 3, so numbers less than 3, and numbers that are greater than negative 3. So x is greater than negative 3. So that inequality, that compound, covers all of these solutions, everywhere in here. All of these numbers are within 3 spaces of 0. So if you notice, this is always going to result as an AND type of compound. Since it's connected in between, we're within, they'll always be connected, and we'll have an AND kind of answer. So we're pretty much going to do the same thing here, but this time I'm going to turn the sign around. So the way to pronounce this is numbers further than 3, or numbers with a distance that is greater than 3. So if we think about numbers that are further than 3 spaces from 0, we would have our negatives and our positives. So for example, negative 3.1, that's further than 3 from 0. 3.2, negative 3.2 is more, negative 4, negative 5, these are all more than 3 spaces from 0. The same with the positives, 3.1, 3.2, 4, 5, those are all further than 3 from 0. So once again, the way that we're going to show this, because there's infinite possible answers for this problem, is we're definitely not going to include the number 3 because it's not inclusive. We want numbers strictly less than negative 3 or more than 3. All of these numbers are more than 3 spaces from 0, have a distance of greater than 3. So an easy way that we can show all of these solutions would be with a compound inequality. Since we have two separate graphs, the first one shows numbers less than negative 3. So any number beyond negative 3 will be more than 3 spaces from 0. Or any number greater than positive 3 will also have a distance greater than 3. So when we look at this, clearly we have to use the word or because they're disjoint, they're not connected. So these kind of answers will be or answers. And that's what makes this unit very tricky, is we have to determine, do we have an and kind of answer or do we have an or kind of answer? And that comes from the graph. So ands will always be connected, whereas ors will go apart. So you'll have to look at your graph and decide which situation do you have. So we'll do a classic example here. We have absolute value greater or equal 5. So step 1, because it's absolute value and it's distance has rules. So if you recall, you can't have a distance equal a negative number. So we were writing no solution if this ever happened because it's not possible for distance to be negative. It's kind of the same thing here. So we have to ask ourselves, is this statement, does that make logical sense? So basically, the first step you need to do is ask yourself, can a distance be more than or equal to 5? Absolutely. So we want to make sure that we have a yes before we proceed. So there will be two cases, and it makes more sense when you look at a number line. So if we're showing distances greater or equal to 5, all of these numbers right here are more than 5 spaces from 0. But down here, we can't forget all of these numbers are also more than 5 spaces from 0. So, for example, -6 is 6 spaces from 0, and that's still more than 5. So we still have to do this case 1, case 2 stuff. So case 1, my answer is either greater than 5 or equal. Case 2, now we got to talk about the negatives. I could get an answer that is less or equal to -5. So you basically are going to copy the problem for case 1. Case 2, you're going to switch the sign and change the answer to a negative. That way, all of our answers that we get will include all possible negative values for x and positive values for x. So if we were to go through and solve this very quickly, we would get x is greater or equal to 1/2. The second answer we would get would be x is less or equal to -4.5. So we can actually plug in anything less than -4.5, and that'll make this true. So for example, let's try -10. So my original problem, I would do 2 times -10 plus 4. That would give me -20 plus 4, which is -16. The absolute value, or the distance, of -16 is +16. So this is a true statement. But we can also use numbers greater than or equal to 1/2. So for example, we'll try the number 4. So if I do 2 times 4 plus 4, clearly that's going to be greater or equal to 5 after I apply the absolute value. So any of these numbers will work to make this true. So we got to make sure we cover all of the negatives and all of the positives that would make that true. So that's the first scenario. The second scenario would be if we switch the sign around. So we have the same problem, but this time we're talking about less than. So very quickly, again, 5 is included, so our number could be exactly 5 or -5. Both are 5 spaces from 0. We also want numbers that have a distance less than 5. So distances less than 5 would also work. So -4, -3, and so on. 1, 2, 3, 4, 5. These are all within 5 spaces of 0. So the first thing we want to ask ourselves is it possible for distance to be less or equal to 5? Well, yeah, it is possible. So again, we need two cases because we need to cover the negatives and we need to cover the positives. So just like before, case 1, we're simply going to copy the problem, but we won't be using the absolute value bars. The case 2, we're still going to use the 2x plus 4, but this time we also want our numbers to be greater or equal to -5. So these should kind of make sense with the number line. Numbers less or equal to 5 versus numbers greater or equal to -5. All of these numbers are within 5 spaces of 0. And if we were to solve this very quickly, once again, we would get the number 1/2, but this time my sign is reversed from what it originally was in the other scenario. For this one, we're going to get x is greater or equal to -4.5. So even though we got the same answers as when the sign was reversed, the signs are reversed of each other. So I know it's very confusing at first, but it really works if you just copy the problem and then simply switch the direction and change it to a negative. If you can remember those two steps, then you can handle these problems just fine. So what we're going to do is we're going to take our two answers from the first problem and our two answers from the second problem. We're going to graph these. We're going to compare how they're different. So I'm going to plot -4.5 and 1/2 on both graphs. We are going to use solid dots since it is inclusive. This one says I want to graph greater than or equal to 1/2, less or equal to -4.5. Versus this one, which wants less than or equal to 1/2 and greater than or equal to -4.5. So we're going to end up connecting these guys. So my last step is now that I can see what's going on, I can finally write my answer as a compound inequality. So all of your answers to these will be compounds because you'll have two answers. So the first one would be x is less or equal to -4.5, or x is greater or equal to 1/2. So that would be the answer for problem number 1. Problem number 2 is an and statement. So we're going to write that as x is less or equal to 1/2 and greater or equal to -4.5. So this is a very complicated kind of problem. It requires your thought process and several steps. So what we're going to do is we're going to stop the video. The next video we're going to pick up by doing the example problems. And that way we'll try to build repetition and hopefully build our confidence.